Once we've set our configuration, we can go through to the straightness measurement screen. The top right hand corner shows the actual values being fed through from the autocollimator. Both X and Y values are shown even though we're going to be doing a single axis in the Y-axis analysis. These can be removed from the screen, but I like to see them to see the live data. To take a measurement, we go to the left-hand icon and press measure, and the first value is shown in the table. Once we have more than 2, the results will actually be shown graphically as well. Once we've taken sufficient data, all of it being shown, you can see we've taken 12 points. If the last measurement is not acceptable, we can go back and we can remove that measurement. If we don't like the last one, we can remove the one before. If we don't like all of the results, we can go back. It will ask you just to make sure you do want to remove all the results, and yes you do, and you proceed. Now let's simulate a real straightness measurement. The tally-vel or ultra mirror will be put in the first position and the first point measured. You'll then move the tally-vel or the mirror for the ultra along the base length distance and take a second measurement. You'll then move again and take a third measurement and continue taking measurements until you've reached the full length of the straightness you wish to measure. Once we've done this, you'll see that we have a table of angles, but because we know the base length is 100 millimeters, this is now been converted into heights for straightness in microns. We can now take this data through for calculation of straightness. The analysis now shows us 3 tabs. One is the table of results in terms of the angle measurement and converted to heights because we know the base length. We can look at the chart itself, and we can look at information that the customer can enter about the company, the operator, the machine used on, different things. The table shows us which line was fitted to the straightness, in this case a least squares line, the minimum value and the maximum value at 0.4 and 0.8 in the table, and the total peak to valley. The slope of the least squares line is shown as a gradient in millimeters per meter, and the step size we used is 100 millimeters. Along the bottom, we can save these results. We can print this single page of results or print all of the pages of results. Here, we can edit the data. If we click on this, the table is shown to us, and if we believe that this angle was wrong, we can double click and type in the true value. Once we've done this, that will be now entered into the data, but please note there is a warning to tell you that this has been manually altered, and this will always happen on the results if they're pulled back to show that somebody has changed the data. We can also go and change the reference line, maybe to a minimum zone instead of a least squares line, and the results will be recalculated. We can output the data, export them as a CSV file. Type in the file name. The data is saved as a CSV. The profile chart is displayed in this time with minimum zone lines. The data is shown, and we can change now the scale to a larger scale format, maybe to make sure that all the results are on the same scale for saving. We can go back down, or we can go back to the default, which is maximizing the chart. Again, we can save the results, print the single page results, print all of the results, edit the data, edit the reference line. Here we'll change back to least squares, go back. You'll see now the data has been adjusted to a least squares, and we can export that data. Finally, the information. We can put in company names, operator names, and materials, and that will then be saved with all of the results. Going back, it will now say if you return, you will lose your data. Do you want to do that, or would you like to save now? Save now, enter the results, and we can come back to those at a later time.